Hi everyone. So let's solve again one of the very good problem asked in GATE 2022. So whenever you see this kind of a question, okay, solve confidently. Don't feel like that. Oh, it's going to be very tough question or kind of a thing, right? So this question was asked from GATE. I mean from analog circuit. Okay, and this question is based on relaxation oscillator. Okay, this is kind of a relaxation oscillator which will produce at the output the square kind of a waveform. So you can also say this is a square wave generator, right? So as the capacitor will charge, okay, so let's see what they are asking. This question was asked in GATE, 2022 in EC paper for 2 marks. So you can do these kind of questions within less amount of time and confidently. So for following circuit with an ideal op amp, the difference between maximum and the minimum values of the capacitor we have to find. So here they have given the op amp, and your output can be plus 15 volt or minus 12 volt, right? And these are the power supplies they are given, and diodes are connected. Okay, so if you have studied oscillators, okay, if you have studied positive feedbacks, right, so you can solve these kind of questions. Or if you have studied Smith trigger kind of concepts, right, and they have given this id I versus V characteristic for the status of diode. If your VD is less than 0, so your diode is going to be off. Okay, so you have to remove the diode. Okay, so your ID is going to be 0, right? In that case, so remove the diode with the open circuit, and if VD is greater than 0 or equal to 0, your diode status will be short circuited, nothing else, right? Okay, so let me draw the circuit and start applying. Okay, so initially we have to consider that, okay, input voltage, I mean your output voltage here is what, 15 volt, you can say. Okay, 15 volt. So you have to check status of this diode and this diode. Okay, what is the status, and replace it and find out the UTP. Okay, upper threshold voltage, and up to that voltage your capacitor will be charged. Let me, okay, so the output of this circuit is going to be like this as far as this circuit is concerned. So this circuit is basically square wave generator. So this will be like this ideally. A square wave generator. The maximum it is 15 volt and the minimum is minus 12 volt. But there is a capacitance. They are asking about the difference between maximum and minimum voltage of the capacitance, right? This is going to be the threshold, the square wave, which will be output of that relaxation oscillator. So this is the oscillator circuit they have given, that is minus and plus. Right, so let me get back and check what, yeah. There is two resistances connected, one resistance. They have given two resistances more, so here they have given two resistances. You can draw the circuit yourself, no problem. So this diode is pointing like this, and this diode will be pointing, I guess, downward, right? Yeah, diode is pointing downward. Now what you can do here is, this is capacitance connected here, resistance. Initially there is 15 volt and minus 12 volt. Okay, so you can say that your V out is given as 15 volts. So you can say this is 15 volt, right? So when 15 volt is there, right, so what will happen is that this D will be off, this D will be off, and this D will be on, right? Once this is given, so this D will be off, so you can remove this D. Okay, this diode will be removed by open circuited, okay, because that will be in reverse bias. So now what you can do here is these resistances, that is all the resistances are R. It is also very easy question they have given R. What you have to do, you have to now find, and this diode will be on. You can replace it by what you can replace it by short circuited. So let me replace this by short circuited because of IV characteristic, ideal IV characteristic they have given. Okay. Now what you can do, you can determine, you have to find the voltage here, that is VUTP. And 15 voltage is there, UTP. VUTP directly by applying voltage division you can find. When this is short circuited, this R doesn't come into picture. So you can say that R upon 3R will be the okay, R upon 3R into 15. So it will be you can say 5. Okay. 5 volt will be the VUTP. 5 volt will be the R upon 3R. I hope this makes sense. Now what you can do, now you just change your output. Okay, when this I mean your output of this op amp will change from plus 15 to minus 12. Okay, so what will happen, your diode status will be changed. This diode will be on and this diode will be off. Okay, so you can say that this is VUTP, and for okay, so this time this diode will be on, so you can say this is short circuited and this is off. Here you have to calculate VLTP. Okay, so this R, this is R, this is R, this is R. So your VLTP will be what? This is after all minus 12 volt. So minus 12 into 2R upon 3R. Right? Because this R will not come into picture. This R will not come into picture because this is short circuit. How easy this is, right? You can see I'm solving questions. So this R and R gone, and this will be 4 minus 8. So this is VLTP, that is minus 8. Okay, so you can see this is minimum voltage and that is maximum voltage, right? This is going to be VC minimum and that is going to be V max. Let me draw here. Your capacitor is charging like minus 8, okay, minus 8 volt minimum, and it will go up to 5. Again it will, okay, and it will, it is going. So they are asking what? They are asking the difference between these 2 points. You can calculate the VC max minus VC min is going to be 5 minus of minus 8, that is going to be 13 volt. I hope this makes sense and this is the answer. If you are able to solve, I mean, if you are not worried about these diodes, you can solve this kind of a question very easily. Okay, so I hope this solution is helpful. So option for this question is going to be 13. Confidently you can answer and within 20 seconds only. 2 marks free. Okay. So we will meet in the next question. Okay. With the again very good solution.